Hello, this is Ms. DB, and in this video we are going to wrap up Chapter 13 with the law of cosines. Our objectives are to use the law of cosines to find the side lengths and angle measures of a triangle, and then we're going to learn a new formula called Heron's formula to find the area of a triangle. So we've already used the law of sines, but that doesn't work for all triangles because we can't use it if we have side angle side or side side side. So instead we have to use something called the law of cosines. And you can look in your book to see how this was derived. But basically we're going to say that a side squared, like say a squared, will be equal to the other two sides squared and added together, so b squared plus c squared, minus 2 times those two sides, b times c, times the cosine of this angle. Now they write this 3 different times just so that you can use any of the 3 angles with the sides and you can see how they go together. So here's an example. We're going to solve triangle ABC. Now they don't always draw the triangles, but I find it helpful to go ahead and put that in there. So I'm just going to sketch a triangle. I'm going to call angle C right here, and then I'll call this angle A and this angle B. So C is 32.2 degrees. Side A would be opposite angle A, and that's 8. Side B would be opposite angle B, and that's 5. So the formula says that, let's write it out, we're going to use the one with angle C in it because we're given angle C. So C squared, which is this side, which we don't know, that this is how we'll find that, will be equal to a squared, which would be 8 squared, plus b squared, which will be 5 squared, minus 2 times 8 times 5 times the cosine of 32.2. So everything gets substituted in there, and then it's just simplifying. So I will have c squared equals 64 plus 25 minus, simplify this as much as you can, 8 times 5 is 40, 2 times 40 would be 80, cosine of 32.2. And then I'm going to keep simplifying, so add the 64 and the 85, that's 89, or 25, that's 89, minus 80 cosine of 32.2. So at this time I'd have to grab my calculator and figure out, yeah, they write the answer right there. So we'll do it in a couple more steps. So I'm going to take the cosine of 32.2. Cosine of 32.2 is equal to 0.846, and now I'm going to multiply that by 80. Okay, so here's what I got when I took 80 times the cosine of 32.2. I got 67.69545, etc., etc. So now I need to take 89 minus that. So 89 minus 67.69545 is 21.30455. Now that's c squared. So I still have to take the square root of that. So when you take the square root of that, if it's already on your calculator, you can also raise it to the 0.5 power or to the 1/2 power so that you don't have to retype everything. That's the same as the square root. So I get that c is equal to 4.6156852, so c is equal to approximately 4.62. So now we know what side C is. So we have all 3 sides now. And they just rounded it to 4.6. So now that we know that C is 4.6, let me sketch this back together. So this was 32.2, and now we know this is 4.6. Did I call A? I called this A here, and this B. So this was C, this was A, this was B. So now that we have this information, we can use that to find the other angles, that the other 2 angles are missing still. So we're going to switch over to law of sines because we have enough information now to use the law of sines now that we found side C. So we can say that the sine of angle B, which we don't know, over side B, which we do know is 5, will be equal to the sine of C, which we know C is 32.2 degrees, and the side C now we know is 4.6. So now we just substitute in everything that we know, and then we use proportions to solve this. So before we get to that point, we would say, okay, I'm going to cross multiply. 4.6 times the sine of B is equal to 5 times the sine of 32.2. So then I can divide both sides by the 4.6 in order to solve for sine of B. So sine of B equals 5 times the sine of 32.2, all divided by 4.6. Now we get our calculators out again, and we type in what is sine of 32.2, multiply it by 5, and then divide that by 4.6. Or you can, especially if you have a graphing calculator, you can just go ahead and look ahead knowing that you need to find angle B, so you're going to be taking the inverse sine. Let's just go back here. I'm going to use my calculator and find the 5 times the sine of 32.2. I got 2.66438, and then I'm going to divide that by 4.6. So I'm going to write this decimal answer here. 0.5792133, etc. There's a few more digits there. So then if that's what sine of B equals, then the inverse sine of that 0.5792133 will be equal to angle B. So then remember, you have to use the shift key or the second key in order to get to the inverse sine function. And I'm typing in all of those decimal numbers, and I get just what they got, that B is 35.39522, etc., which they rounded to 35.4. Okay, so now we know angle B is about 35.4 degrees. Now the only thing left to find then is the other angle. So now we know that we have 32.2 for angle C, we have 35.4 for angle B, so we can just take 180 minus angle C minus angle B to find the missing angle, and then we'll be all done. We'll have all the parts of the triangle solved for. And whoops, there it is. It is about there, 112.4. Okay, so here is your problems from your worksheet, some of them, and you're going to figure out using the law of cosines. First thing that you'll be trying to find is side D, and then we'll switch over to law of sines to find one of our other angles, and then we'll use the triangle sum theorem to find the other angle. So the formula, once again, let's look back at the formula for law of cosines. And it can be this one, or you can use the other versions of it. So it's one side squared equals the other two sides squared and added together, minus 2 times those sides, and then the cosine of the angle that is opposite the side we're looking for. All right, so let's use, now these are DEF, but that doesn't matter. So let's say that the cosine, I'm going to use D. So I'm going to say that D squared will be equal to, this is E and this is F. So it'll be equal to E squared plus F squared minus 2 times E times F times the cosine of D, which is 24. Okay, so now we'll take D squared, which I don't know, I'm trying to find, and E squared is 25 squared, and F squared is 22 squared, minus 2 times 25 times 22 times the cosine of 24. So it's not a lot of hard math, but you just have to be careful that these are kind of big numbers, so when you square them, you have to make sure you put them all in correctly. So then we would take 25 squared is 625, 22 squared is, Oops. Using my calculator here, 22 squared is 484. 2 times 25 is 50. 50 times 22 is 1100 times the cosine of 24. So you can also type all of this into your calculator at once, especially if you have one that shows your different parts. As you can type the whole thing in and see it. So I'm going to take cosine of 24 now. Cosine of 24 is about 0.9135, and I'll multiply that by 1100, and I get, and then I subtract, and remember this is d squared. So d squared is equal to 1109 minus 1004.9. Oops, I forgot a 0 there. And then we take the square root of both sides to solve. And I get about 10.2. So once you know side D, you're not done, because I also have to find angle E and angle F. But now I can switch over to using law of sines. Okay, so now I'm going to use the law of sines. Let's see, I'll switch my color here to green. So I'm going to use, I'll do sine of 24 over side, so I'm going to do these two over 10.2 would equal the sine of E over side E is 25. So 25 cross multiply times sine of 24 equals 10.2 sine of E, and I'm trying to find E, so I'll divide both sides by 10.2, and this will give me the sine of E, and then I'll have to take the inverse sine in order to solve for that. So sine of 24 is about 0.4067. I need to multiply that by 25. So I get 10.1684 and divide that by 10.2. So I get that the sine of E is equal to 0.9969. And now I need to take the inverse sine of that 0.9969 in order to find what angle E is equal to. So I use inverse sine of 0.9969 is equal to 85.48. So E is equal to 85.487, so I'll round that to 0.45. Now all we have to do now is find angle F, which we can do by subtracting the angles that are known from 180. So that's the easiest part, is that last step of taking 180 minus 24 minus 85.45. So 70.55 would be angle F. Measure of angle F is 70.55 degrees. So there we go. Now the directions will tell you to pick certain ones of these. You don't have to do all of them. So you can pick number 3 that we just did and do that one, and then you'll have another one to do on your own as well. Sometimes when you use the law of cosines, we're given 3 side lengths and no angles, and it still works out. So here's how you do this one. First, you plug in the formula, and in this one we decided to find angle B first, but it wouldn't really matter. So b squared is equal to a squared plus c squared minus 2ac times cosine of b. Then plug in your a, b, and c, and then use your calculator to help you simplify each part of this. Now they did it all in one magical step, but I would write 81 equals 64 plus 49 minus, let's see, 2 times 8 times 7 is 112 And then we added these together and subtracted from 81. Let me give myself a little more room here. So 81 equals 64 plus 49. That's 113. And then we have to subtract 113 from both sides. So there is a lot of math here. And that's negative 32. So we get negative 32 equals negative 112 cosine of b, and then divide by negative 112. So negative 32 divided by negative 112 is equal to this, 0.2857. So that's equal to the cosine of b. So the inverse cosine of that, 0.2857, that's what's equal to angle B. And if you use your inverse cosine on your calculator, you'll find that that's 73.4. So that's your first angle. Then you can use the law of sines to find the second angle, or you can use the law of cosines again. It's really up to you at this point if you want to use the law of cosines again, or if you want to switch to law of sines. As soon as you know one angle measure, you could use law of sines to find the other angle measure. So here it is using law of cosines. I'm not going to go through every single step, but they found that the other angle is equal to 48.2. And then once, of course, you know two of them, you can just subtract from 180 in order to find the third angle measure. All right, so on your worksheet, again, it'll say pick from so many to do, 2 out of this section. So here's some that have where we know 3 sides. So let's say that I'll say d squared. This is d, this is f, this is e. So d squared would be equal to e squared plus f squared minus 2ef cosine of d. So d squared would be 15 squared, now it's just substitution, equals 13 squared plus 26 squared minus 2 times 13 times f is 26 cosine of d. We don't know d, so we just write d there. And then you simplify all of this and you solve for cosine, you solve for d. You'll get a decimal equals cosine d, then you use inverse cosine to find that. So 225 equals 169 plus 676. And then 2 times 13 times 26 is 676. Wait, what is 26 squared? This was supposed to be 676 here. And then this also equals 676 cosine d. And then I'm going to add these two together. 169 plus 676 is 845. Subtract 845 from both sides. It's negative 620, and it will be negative because over here we also have a negative. And then I'll divide both sides by negative 676. So we have negative 620 divided by negative 676 is 0.917159. I'll write the whole thing out, but you'd leave it on your calculator. Now that's equal to cosine of d. Now we're going to take the inverse cosine of that, 0.91715963, and that will be equal to the measure of angle d. Okay, so inverse cosine, 0.91715963 is 23.485 degrees, or you can round that to 23.49 degrees. So we have one angle right here, 23.49, and I think I would switch to law of sines. I like that better. And I would say that the sine of 23.49 degrees over the side opposite is 15 would be equal to the sine of E over side E of 13. And I would cross multiply, cross products are equal, and then I would find angle E that way. And then again, once you know two of the angles, you can just subtract from 180 to find the other one. And you can finish it up. And then the last thing that we're going to go over is another way to find the area of triangles, and that is called Heron's formula. This works very good if you know all three sides of the triangle, but not any angles. And this is the formula for that. And it comes from law of cosines, but again, you can look in the book to see where it comes from. So we're going to take half, we're going to add these three sides together, that's the perimeter, and take half of it and call that S. That's S in the formula. And then we take S times S minus A side times S minus B times S minus C and take the square root of all of that. All right, let's see it done. So our sides are 2, 6, and 7. So I'm going to draw a triangle. Oh, that triangle would not look like 2, 6, and 7, would it? Something like this, 2, 6, and 7. And I am going to use the formula to find the area of this triangle. So the first thing to do is find the perimeter and then take half of that. That's your S. So 2 plus 6 is 8 plus 7 is 15. So S will use 7.5. Once you know S, then you're ready to use the formula, which is S, and then A was 2, B was 6, and C was 7. So we have 7.5, and then 7.5 minus 2, 7.5 minus 6, 7.5 minus 7. So you subtract each side from that 7.5. And then it's just simplifying. So we have 7.5 times 5.5 times 1.5 times 0.5. And if you multiply all of this together, let's see, 7.5 times 5.5 times 1.5 times 0.5 is equal to 30.9375. And then we take the square root of that to get they rounded already, 5.562, which they rounded to 5.6. And that is the area of that triangle. And then they're checking it with another method, which I probably wouldn't do because law of cosines takes a really long time. Okay, so here's a couple problems from your assignment. And remember, the first thing you have to do is find S, which is the perimeter divided by 2. So you find that first, and then once you know what S is, then you're ready to plug that into the formula. So let's see, S is 14 plus 19 plus 21, which is 54, divided by 2 is 27. So now we know what to use for S. So 27, and then we go 27 minus 14, 27 minus 19, 27 minus 21. And then we just simplify. So we have 27 times 27 minus 14 is 13. 27 minus 19 is 8. 27 minus 21 is 6. And then multiply all of those numbers together. 27 times 13 times 8 times 6 is a big giant number. Whoops. (27 times 13 times 8 times 6 is 16,848, and then we take the square root of that, and our area is approximately 129.8 meters squared. That was a pretty big one. All right, that wraps us up for today. If you have any questions, please let me know.